All right, we're going to get started on 4.5. God bless you. 4.5, loop analysis. Okay. So it says here, in this lesson, you will practice tracing code with loops and analyzing loops to determine how many times they run. Okay. So we're just going to be looking at, I'm guessing, while loops, for loops, and just tracing it step by step. It says in 4.5.1, let's practice tracing through loops with many variables. Remember to make a tracing table to keep track of all the variables and iterations. Now, I'm someone that cannot do math in my head very well. Is anyone else like that? You need to write things down. I need to show my work. So when I have students in my math class that just don't show their work, I don't get it. One, I want to be able to make sure and see where you went wrong if you got the question wrong. And two, I just don't know how people do math in their head. Never works for me. So make sure to trace loops. I have someone just in the chat said, I've struggled with loops. Yeah, it's sometimes hard to go through and trace those loops and even maybe just write the loops consistently. Luckily, the more that we go through this, the better we will get at it. So let's practice. We get better by practicing. Okay. It says here is a complex loop, which means it's kind of difficult. See if you can trace the code on paper by making a tracing table to predict what the code will do when you run it. Okay, which means we're going to write the variables and keep track of the variables and the changes throughout it. The question says, can you trace through this code? Add in output statements, system.out.println, before the loop and inside the loop at the end to keep track of the variables and run. Okay, so let's just look through what we have so far. Okay, I have an integer. I'm going to write these down. var1. Oh, I don't want to use that. Do I have a pen over there? Yes, I do. All right, cool. We're going to say var1. I was writing with an expo marker, and that never ends up well. var1 is assigned the value of 3 right there in line 5, right? And var2, which is just another variable, it's an integer, is assigned the value of 2. So this is like what I wrote on my piece of paper, right? Just var1 is 3, var2 is 2. Now, while var2 is not equal to 0 and var1 divided by var2 is greater than or equal to 0, this is not stuff I could do in my head, so I'm glad I wrote this down. So first, let's see if it runs the first time. Okay, var2 is 2. Is 2 not equal to 0? Yes, so this part is true. And, which means both parts need to be true, var1 divided by var2, so it's 3 divided by 2, that's 1.5, is greater than or equal to 0. Is 1.5 greater than or equal to 0? Yes. So they're both true, so it will run. Okay, so here's what we'll do. We'll take var1 and we'll add 1 to var1. So var1 was 3, var1 is now 4. And var2, we're going to subtract 1 from it. Okay, so var2 was 2, now it's going to be 1. Okay, so right now var1 is 4 and var2 is 1. Now let's loop through. So we went through one time. So I'll say one iteration. I made like a tally. Now let's see what it looks like now. Is var2 not equal to 0? Well, var2 is 1, so that's good. And is var1 divided by var2? var1 is 4. 4 divided by 1 is 4. Is 4 greater than or equal to 0? Yes, it is. So it would run the second time. So I'm going to write a tally here. Now our variables change. var1, we're adding 1 was 4. Now it's 5. And var2, we're subtracting 1 from it. var2 was 1. Now var2 is going to be 0. Okay, so right now var1 is 5, var2 is 0, and we've looped through twice. So now let's read through again. Okay, let's see if we can loop through a third time. It says while var2 is not equal to 0. Well, hold on. var2 is equal to 0. So I'm going to short circuit out of this loop because this is not true. And it's an and symbol. They both need to be true to run. And since it's not true, it will only loop through twice. Right? So if we print that out. Okay. It goes through and it keeps track of it each time, printing out the variables, right? So with that, we were able to loop through the first time with the variables, the second time, and then that third time we were able to go through there. So keeping track of the variables, right? We have this, this, and this. Originally it was 3 and 2. Then we changed it to 4 and 1. Okay, then we change it to 5 and 0. Did your trace table look something like this? Sure. All right, I think now I've hit a point where in Honors Java, we never actually got this far. So we've officially surpassed an entire semester of Honors Java, right? Right? Pretty cool, right? Just over a quarter. So now you won't see these like pre-answered values on here. All right. It says, what are the values of var1 and var2 when the code finishes executing? So var1, I'm writing my little table here, var2, var1 is 0, and var2 is 2. It says, while var2 is not equal to 0, well, that's true because var2 is 2. And var1 divided by var2 is greater than or equal to 0. Okay, so var1 is 0, divided by 2 is 0. 0 is equal to 0, so that's true. So we're going to go ahead. This is true right here. This is true right here. Let's move forward. We're going to add 1 to var1, so 0 will now be 1. And we're going to subtract 1 from var2. So var2 will now be 1 as well. So after looping through one time, var1 is 1 and var2 is 1. Let's look at this. If var2 is not equal to 0, well, 1 is not equal to 0. So this is true. And var1, 1 divided by 1 is greater than or equal to 0. Well, 1 divided by 1 is 1, and that is greater than 0, so that's true. So now we're going to go through a second time here. It says var1, we're now adding 1 to var1, so var1 will now be 2. And we're going to subtract 1 from var2, so var2 was 1, and now that's going to be 0. Okay. It says, what are the values of var1 and var2 when the code finishes? Well, let's see here. var2 is not equal to 0. Well, var2 is 0 right now. So that can't happen. So this is false. So that's going to short circuit out. The current values are var1 is 2 and var2 is 0. So the answer is going to be B. Okay, I'm literally just using this index card right here to write things down. On the AP exam, you can write them down as well. It's just how I'm tracing it. I have this huge stack of index cards over here. So if you guys would like index cards to use, you can. But you can also use a regular sheet of paper. All right, another one. What are the values of X and Y when the code finishes executing? Okay, I'm going to make my table. If I have an X and a Y value, X is assigned the value of 2, y is assigned the value of 5. You might just be able to do all this in your head. That's great, right? Maybe that's for you. I realized very quickly in my math career that I could not do math in my head. I have to write things out. I show every step to the point where I'm like so slow. I got to honors pre-calculus and I had to drop to regular pre-calc because I'd take tests and only finish the first like 8 problems and leave the last 2 blank. And I'd get all 8 right, but I just didn't get to those last 2 and I didn't have extended time. And my teacher would ask, I'd say, hey, can I finish? And they'd say, oh, well, you didn't complete it in the allotted time. So because I couldn't finish the test, I was getting like 80, 70% on the test. I'd get everything right that I did because I was very slow when we go through it. But I just needed a class that wasn't moving so fast. So I dropped from honors to regular and then got 100% in that class, right? So sometimes it's okay. Don't feel like you have to be able to take all honors classes if you're struggling with things. If you need a little slower, that's fine. I always needed things just a little bit slower and broken down. So if you need to write things out like I do, then do it by all means. So I'm going to write this out. Int x is 2, int y is 5. It says while y is less than 2 and x is less than y. Okay, so y is 2. Let's look at this condition. Okay. Is y greater than 2? Well, y is 5. 5 is greater than 2. So that's true. And is x less than y? Well, x is 2 and y is 5. So that's true as well. So both conditions are true. So we're going to run the loop. Okay. We're going to take x and we're going to add 1 to it. So 2 becomes 3. We're also going to take y and we are going to subtract 1 from it. So 5 becomes 4. Okay. What are the values of x and y? Well, we're going to keep going and see. We ran through 1 iteration. So now y is 4. Is 4 greater than 2? Yes. And is x still less than 3? Or sorry, is x still less than y? In this case, x is 3 and y is 4. So that's true as well. So this condition is true. This condition is true. Since it's an and, we're going to go ahead and continue with the loop. Okay, we're going to add 1 to x. X was 3. Now it's 4. We're going to subtract 1 from y. Y was 4. Now y is 3. Okay. So now let's go back to our loop. Okay, while y is greater than 2, well, y is 3. 3 is greater than 2, so that's true. And x is less than y. X is 4 now, and y is 3. Is 4 less than 3? No. So this part is not true. It's false. The first is true. The second is false. This is an and, so it needs both to be true. So it will not move further from here. So my x value is 4, and my y value is 3. So that is E. Okay. Moving through here, it says, how many stars are printed out in this loop? How many times does the loop run? Figure it out on paper before you run the code. Lovely. Okay. So we have a for loop. Okay. We have our main method. We have a class called count loop, our main method inside of it, public static void main string args. And then we have our for loop. We initialize this variable I, and it's 3. As long as I is less than 7, the loop will run. And after every time the loop runs, we're going to add 1 to I. Okay, so the question is, how many stars are printed out in this loop? Which means really, how many times does it go through? We will test it out. Okay, so I is 3. 3 is less than 7. So we're going to go ahead and add 1 to it. And we're going to print out 1 asterisk. Then we come back here. I is now 4. Okay, is 4 less than 7? Yes, right? So we're going to add 1 to it, and we're going to add an asterisk. So far we have 2 asterisks, and I is 5. We're going to come back up here. Okay, is 5 less than 7? Yes, we're going to run it again, and I will be 6. So I have my third asterisk that I'm going to print out here from this line. Okay, I is 6. Is 6 less than 7? Yes, I'm going to add 1 to it and print out the asterisk. Okay, now I is 7. Is 7 less than 7? No. So I've printed out 4 asterisks so far. I guess it would look like this. I just put Python. Sorry, guys. You're wondering why I put that hash symbol there. So it should look like that. 1, 2, 3, 4 asterisks. Let's run it. Yep, that's what we got. Okay. So you see, sometimes I'll run my code early without like reading through everything. I used to be so afraid to run my code that I was going to get an error. And whenever I got an error, I just shut down and be like, oh, don't know what to do. And then I realized that like sometimes it's good to run your code as is and not be perfect. So that way you can figure out the mistakes you're making as you make it, instead of writing this huge lengthy code and then have all these errors at the very end when you finally run it. When someone comes up to me in my AP Computer Science Principles class and just has like 37 errors in their code, it's because they never ran their code and they're just like copying exactly what I'm doing, but never running it. So with that, please make sure you run your code. It's good to make mistakes. It's good to have predictions. And sometimes I think it's going to run properly and it doesn't. And then I can fix my mistake. Okay. You'll hear me sometimes say, hey, let's see if this runs, right? Should be right, but sometimes I make mistakes. You guys make mistakes too. So if you made a trace table, which we did, blah, blah, blah. The number of times a loop executes can be calculated by the largest value minus the small value plus 1. Yeah. Cool. Loops. Loops are fun. In the code above, the largest value that allows the loop to run is 6. Cool. How many stars or asterisks are printed out by the following loops? How many times do the loops run? Calculate on paper before you do it. Why do you think they're telling us to calculate it on paper? Why do you think this is the reason why? Okay, so you can see your mistakes. That's one reason. What else?
So that we can like go through the process, kind of like how computer goes through the process to see how we get to the answer.
Okay, so the process of following what the computer does, the computer obviously does it a lot faster than us, but seeing what it's capable of, seeing what it does, but also because on the AP exam, right, you're not going to have, like, you're going to be writing your code out, right? So the more that we are writing this, the more that we are tracing this, the better it will be when you actually face these types of problems on an exam, right? All right. You all right, Greg?
Yeah.
He's just like hanging out over there. All right. How many stars are printed by the following loops? So let's see. So I have an int row, and row is assigned the value of 0. I have an int column, and column or col is assigned the value of 0. Okay. What this should do is this should give me 5 rows and should give me 10 columns. Just looking at this, I'm not going to go through this 50 times because a 5 row by 10 column thing is 50 asterisks. But I'll go through the first example, right? So the first row, it's saying row 0. It does this and it prints it prints out all the columns, right? It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? it will go through and print the entire first row out. And then it will come back here, add 1 to row, and move down to the next row. Okay, so this is because the print line moves it down to the next row. So this will give you a 10 across by 5 rows. So 10 columns, 5 rows. Let's look at it. Okay, 5 rows, 1, 2, 3, 4, 5. Rows go left to right, and columns go up and down. So we could trace through every single example here. I just see that we're starting at 0, we're stopping at 5, we're starting at 0, stopping at 10. That is 5 by 10. Okay, programming challenge. We encourage you to do this activity as a process-oriented work in groups. Yep, we are working in groups. We're in one big group. Do the following exercises in your group. Make sure you draw the trace tables, keeping track of all the variables in the loops. Use the formulas to determine how many times the loops run. If the group finishes early, do some multiple choice problems. We're going to do this. Okay. So says we're going to go through each of these. How many times does the code print an asterisk? Okay. So this is a outer 4. So we'll run when it's 3, 4, 5, 6, and 7. So that's 5. So this is going to give me 5 rows. Okay. Now down here, it's if y is starting at 5, or sorry, y starting at 1 stops when it's 5, it will give me 1, 2, 3, 4 columns. So it should be a 4 by 5. So it should be, or sorry, it should give me 5 rows and then 4 columns. 5 times 4 is 20. So the answer should be B. Okay. How did I come up with that? So 3 works, 4 works, 5 works, 6 works, and 7 works. 8 does not work. So that's 5 rows. And then down below, 1 works, 2 works, 3, 4. Those are 4 values. So 5 times 4 is 20. Okay. Let's look at this one. What does the following code print? 2 works, 3 works, 4, 5, 6, 7. Okay. 8 does not work. So that gives me 6 rows. So I know it's either C or D. 6 rows by, let's see how many columns. If y is 1 right here, right? If y is 1, 1 works, 2, 3, 4, and 5 works because it's less than or equal to, right? So it's 6 rows by 5 columns. So a rectangle with 6 rows and 5 stars per row. C. All right. What does the following code print? 3 works, 4, 5, 6, 7, 8, 9. Okay, so that's 7 rows. Now notice here we are subtracting, right? So I have 7 rows. I know it's either C or D. Let's look at this. As long as J is greater than 0. Well, 6 works, 7 works, or sorry, 6 works, 5 works, 4 works, 3, 2, and 1. Okay, so that's 6. So we had 7 rows and 6 columns. So that would give me D, a rectangle of 7 rows and 6 stars. All right, we got one more. says, consider the following code segment. How many times is the string hi printed out as a result of the following code executing? All right. My variable is starting off I. It's assigned the value of 0. Is 0 less than or equal to 4? Saying how many times does hi print. Okay, so we'll keep track of that in the end. 0 is less than or equal to 4. Okay. So what we're going to do is we're going to take j. J is assigned the value of 0. Is j less than 3? Yes, it is. So we are going to run hi. I'm going to make a tally here. Then we're going to add 1 to j. So j is now 1. Okay. Is 1 less than 3? Yes. So I'm going to print hi again. So I'll make my tally 2. Add 1 to j. So j is now 2. Okay. Is 2 less than 3? Yes, it is. So I'm going to go ahead and add 1 to it. And I'm going to print out hi again. So j is now 3, and we've printed out hi 3 times. Okay. Now, is 3 less than 3? No. So this for loop right here is done. I'm going to add 1 to I. So I is now 1. And I'm going to come back up to my while loop. Is 1 less than or equal to 4? Yes, it is. So I'm going to run my for loop again. Remember, that for loop last time ran 3 times. So is it safe to assume that this loop will run 3 times again? It is. So I had 3. I'm going to write 3 more tallies, which would be 6. Then I'm going to add 1 to I. I is now 2. Is 2 less than 4? Yes, it is less than or equal to 4. Okay, so it's going to run this for loop again. Is it safe to assume that's going to run 3 more times? Yes, it is. So I'll make 3 more tallies and add 1 to I. So I is now 3. Okay, it looks like this will run this time and 1 more time when I is 4, right? So I'm going to go ahead and write 3 more tallies 2 more times. If I count up my tallies, I have 15 tallies. It ran 3 times, then it ran 3, 3, 3, 3. The reason is each time this runs, it prints hi 3 times. Okay. How many times did we do the outer loop? Well, 0, 1, 2, 3, and 4. That's 5 times. So it's going to loop. The for loop's going to run 5 times. And if each time it gives me 3 highs, 5 times 3 is what? 15. So A must be 15. Summary. Trace table. That's what I was making this entire time. Look, here's 1. Here's 1. Here's 1. Here's 1. You guys all see them, right? There's another one. There's another one. All my note cards. All my trace tables. We can determine the number of times a code segment will execute with a statement execution count. This is called runtime analysis. I'm not sure when we talked about that. Maybe I. Yeah, I was about to say, I remember using it before, but didn't know that was summarizing this in here. We're analyzing. I almost said analyzing. We are analyzing these loops and stepping through them. Number of times a loop executes can be calculated beforehand. We've been doing this by taking the largest value, subtract the smallest value, and then add 1. Okay. The number of times a nested for loop runs is the number of times the outer loop runs times the number of times the inner loop runs. In that last example, we took how many times did the outer loop run? 5 times. The inner loop would run 3 times each. 5 times 3 was 15. We figured that out. Multiplication, we know our math. All right. Loop analysis game. Try the game below to practice loop analysis. Okay, so I'll click on loops. And it says, how many times will hello be printed out? Okay, 1 works, 2, 3, 4, 5, 6 will not work, so I'm going to say 5. Okay. If I is 3, as long as it's less than, and we add 2 to it each time, looks like it will only run 1 time. And you can play with this. We'll do one more. 1 works. We add 2 to 1. That gives you 3. 3 works. Add 2 more. That gives you 5. 5 works. So it should go through 3 times. All right. So you can play with that. 10 out of 10 activities completed on this page. Congrats. Well done. And that is 4.5 loop analysis. That's unit 4? What? No way. It was quick. It says unit 4 summary. In this chapter, you learned about loops. Loops are used to repeat a statement or block of statements inside a pair of curly braces. Okay, the body of the loop is what's inside, right? That makes sense. We talked about for loops, infinite loops that move on forever, right? What is a loop? It's a way to repeat. You may hear the word iteration, right? A nested loop is a loop inside of another loop. Remember the nesting dolls? Talked about nested conditionals, an if inside of an if. We also have nested loops. We use those with for loops right there. Out of bounds error occurs. It says if we go past the last number in the string, when we were looking at indexes and we were looping through, that's one error that occurred. How do you trace your code? You do this. You write things down. And a while loop. It will repeat as long as that condition is true. Okay. One loop inside of another, that is a nested loop. A loop that has 3 parts: initialization, the condition, and the change. That is the for loop, right? We typically know how many times the loop's going to run before we run it. And then a while loop will keep on going as long as the Boolean condition is true. You are correct. Writing down the values of variables for each execution of the loop body, that is tracing your code. A loop that never ends all the way to infinity. It's an infinite loop. The statement or block of statements following a loop header that is repeated, that is the body. Common mistakes. Sometimes it says forgetting to change the thing you're testing in the while loop, and you never actually change the condition, right? We initialize it and then never actually add anything to it. That's one common mistake. Another thing, it says getting the start and end conditions wrong for the for loop, so it runs too many times or not enough times. Jumping out of a loop too early. Here's an example of a while loop that doesn't ever change the value in the loop, so it never ends. If you run it, refresh the page to stop it. If I ran it, it was just going to print 3 over and over and over and over and over again, right? So what would I put inside this in line 9 to make sure that I'm incrementing it each time? What can I do to the value of x? Josh.
You could.
I was talking about that one, right? I don't know. Why don't you guys both say it at the same time?
Add an x minus 1.
Minus minus. You're saying X. So if you keep adding, it will run forever, right? Because it's as long as it's greater than. So yes, X minus minus. And then I need my semicolon there, right? I need, so that way it will run 3, 2, 1, and then stop. It counts down from 3 to 1. All right, here's an example of going past the bounds of a string. This code should double all but the first and last letter in the message. Fix the code so it doesn't cause an out of bounds error. Okay. So if I have the position starting at 0, since it's starting at 0, do we maybe want to subtract 1 from the length? Would that be what we're wondering? What we want? Subtracting 1 from the length. Let's try it. Any day now. Finally, compiling and running your code. Maybe everyone is. All right, it works. It says, watch out. Okay, here is an example of jumping out of a loop too early. The code below is intended to test if all of the letters in a string are in ascending order from left to right, but doesn't work correctly. Can you fix it? Okay, so it gets out of the loop too early. Let's fix this. Well, first it says fix code so it does not be looped too early. When should you return true or false? Let's just see what it returns first. Should return false, false. Okay, so we created this class loop3. I have is in order, right? I'm passing a string argument, well, parameter. Once that parameter is being passed in, it's referred to as check. It checks the length. It says position check length -1. Let's go down to our main method and then just trace it. We'll move from there. So I have system.out.println is in order ABCA, and then is in order ABC. So let's look at this. Is in order ABCA. It passes ABCA into this check variable. So I'll trace it. Check is ABCA. Okay. While and my position is 0. Okay. As long as 0 is less than check the length -1. So it checks the length of ABCA, which is 4, and it subtracts 1 from it each time. Or sorry, it subtracts 1 from it because if I'm starting at 0, it will give me the 0 index, the 1, the 2, and the 3, right? As long as it's less than 3. What happens here, though, is when it does that, it never actually includes it. What I can do is I can do one of two things. I can either make this a less than or equal to, or I can get rid of this -1 there. Let's run it. Oh, I guess I got to figure out the rest of the code here. Because while position is less than whatever the length is, so it'd be 0, 1, 2, and 3. Let's follow through and read through the rest of this rather than me just stop early. It says the string letter 1 is assign the value of check. The substring would be from 0 to the position plus 1, and then everything beyond that. So letter 2 is check the substring, position plus 1, and position plus 2. Okay. If letter 1 dot compare to letter 2 less than 0, what should one of these values be changed? That's what it's really looking for. Should be position plus 2. What should be the number here? Remember, the first item, true does return true here, right? But for some reason, this is still showing up as well. Letter 1 dot compare to, let's finish looking through this and see if it helps. Letter 1 dot compare to, I have letter 2, as long as it is less than 0, return true. My position, I then add 1 to it each time. If anything else, it will return false. So we want ABCA should return false, but it's returning true because it's only looking at what values from the position, which is 0. Check substring 0 to 1. That gives me the first letter. Okay. Then it takes the second letter, the second index, all the way through the next one. Okay. And it says if letter 2 is compared to, if that second letter, whatever that next letter is sorry, if letter 1 is for some reason less than 0, then it returns true. Okay. So it looks at A. Is A less than B, right? Because this number, the compare to, if we look back and remember, compare to will return a positive number if it's greater than, and it will return a -1 if it's less than, and a 0 if it's the same, right? So it gets all the way here, and it says, okay, if A, B, C, right, it stops after C, what makes me continue and make sure it checks this A? What can I do? Anyone? Let's walk through this. Position 0, while 0 is less than check length, okay, the length of the first one should be 4, okay? Is 0 less than 4? Yes. So it will run. I go through here and find that position 0, 0 plus 1 gives me the second letter, or gives me what I want to take as my first letter, which is A. The second letter it pulls is B. Okay. Now, A, B, C will work, but it stops here at the A when I compare to, because it will get to C, right? C is my first letter. And then it will run and say, okay, A is my second letter. It compares C to A. What do I need to do here? You guys can play around with it for a minute if you want.
Well, I know that if you change the second, like if you make both position pluses, position plus 1, like if you change the 2 to 1, you will at least get the second body to be like you'll pass the second one. Because right now the actual is true, but if you change that 2 to a 1, then it will make the second one false.
Okay.
But you have to solve it doesn't change the first one.
Right. So just a reminder, it says, making sure when we're actually returning the true and when we're returning the false, right? Could it be that we're returning true too early here? Could it be that we're returning false too late? Is that us? That's the lunch, right? Yeah. Okay. So false, this should say the expected, the actual, this is saying true right here, ABCA, when it should not be returning true because it only goes through anyone? All right, I'll let you guys work through this to finish it, but I'm not going to move on until we go through this. This is where we will end today in 4.6, but I want you guys to work through this and look through this and try and figure it out on your own. Okay. These are types of problems that I want to make sure we're reading through, taking our time, and not just speeding through every single time. So yeah, I'll go ahead and stop there. And you guys can work through that problem.